So we begin question 7. A sequence of designs is made using black disk and white disk. The first 3 designs in the sequence are shown below. So the first 3 designs, so notice in the space provided on the diagram, draw design 4. So notice design 1, we have 3 full dot here, then 4, then 5. So design, I imagine design 4 should have 6 of these. So should have 6 of these. So 1, 2, 3, 6. The second, notice the second one, so we have this going up. So we have 3, then 4, then 5. What the top one is unshaded. Alright, so 1, 2, 3, and 5, and then the top one is unshaded, right? So something like that. And then that's it. And the others, everything else now will be unshaded. So this have 3, 4, then 5. First one shaded, so 2, 3, 4, 5, 6. So that should be it. So that's a pattern there. Good. So that's design 4. Alright, now part B, the number of white disk W, the number of black disk B, and the total number of this T. Alright, so we have a pattern there. Let's look at the table. We have a pattern there. Let's see if we can pick up this pattern here. So design number 1, 2, 3. Notice the number of white disk. 1 times 1 plus 1 plus 1 is 3. Here is 2 times 2. So notice it seems like this design number times itself, design number square, alright, plus the design number plus 1. Alright, so this should be design number, this is 9, so it will be 9 times itself. So 9 times 9 plus 9 plus 1. Now, 9 times 9, that's 81. 81 and 9, that's 90. And 1, so this is 91. Alright. So obviously this is 20. That's 20 times 20 plus 20 plus 1. Alright. So this is what? N times N plus N plus 1. Alright, and this, of course, this will be equal to N squared plus N plus 1. If you want to, so this is actually N squared plus N plus 1. Alright, over here, let's look at what pattern we can find here. So notice these are going up by 2. Alright, and going up by 2. So let's see how we get these values now. And sometimes a little trial and error is involved here. So this seems to be the number here times 2 plus 2. So you check this. 1 times 2 plus 2, you get 4. 2 times 2 plus 2, you get 6. 3 times 2 plus 2, you get 8. So 9 times 2, that's 18. 18 and 2, 20. Alright, here. 20 times 2, that's 40, and 2, that's 42. N times 2, that's 2n plus 2. Let's check if we can pick up a pattern over here now. Now, for the final column, it's a bit tricky, or not, depends on how you view it. Notice the final column is a summation of the second and third columns. So, notice 3 and 4 add to give 7, 7 and 6 add to give 13, 13 and 8 add to give 21, 91 and 20 add to give 111. So here now 421. So 421 plus 42, that would add to give 463. So 421 plus 42. And over here n square plus n plus 1 plus 2n plus 2. So you actually have n square plus, and this n, add to this n, that gives us 3n. And then add the constant 1 and 2, that's plus 3. Stephen Stephen has 28 discs and 154 white discs. 28 black discs, 154 white discs, and wants to make design 12. Explain why it is not possible for him to make design 12. No, let's look here. Design 12. Let me put 12 here. Design 12. Let this call this 12. Let me use a change the color. Let me just change the color. If design 12, if I'm using the design 12 will be the number of white discs will be 12 times 12, which is 144. 12 times 12, which will be 140. 12 times 12 plus 12 plus 1. Now 12 times 12, that's 144 plus 12, that's 156, and that's 157 white discs will be needed. And the number of black discs, let's work again. So 2 times, this thing here is 2 times n plus 2, so 2 times 12, which is 24 plus 2, it will be 26 black discs. And then the total number of discs will be 26 plus 157, so it will be 183 discs that will be needed. So if you're asked to design 12, Stefan has 28 black discs. Alright? So of course, and you need 26, so you have sufficient amount of black discs. 154 white disc, which is not possible. So to make design 12, you need 157 white discs. Stephen has only 154, so not possible. Not possible because 157 white discs are needed. White discs, sorry, are needed. So 157 white discs are needed. He only has 154. Question 8. Complete a table for the function. Alright, so the function, so we have some missing y values, so we need the first missing y values when x is negative 3. So we're going to replace x is negative 3 in the thing here. So substitute x equal minus 3. So we know y equal to minus. Now think of negative x squared as negative 1x squared. So negative x squared as negative 1x squared. And x is negative 3, so minus 3 all square plus x is negative 3, minus 7. So this is positive 9 times minus 1, so that's minus 9. And this is minus 10, so that's minus 19, right? That's minus 19. Substitute x equal negative 2 this time. So it's minus 1. Replace x now with minus 2, so that's minus 2 square. So, alright, minus 2 square, minus 2, my bad, this is actually plus 7, so an error was made here, so this will be negative 9. So this is minus 9, minus 9 plus 4, that's actually minus 5, right? This is minus 5. This, so minus 2 plus 7. Alright, so this is actually minus 4 plus 5. That's 1. Oh, it's there already, 1. Alright, so negative, and x is negative 1, so we didn't need to do this because we already have that. When x is 1, sorry, y is equal to minus 1 times 1 square plus 1 plus 7. That's minus 1 plus 8, that's 7. So this would be 7. What's happening here? When x is, well, when x is 1, it's 7. X is 1 is 7. When x is minus 1, so when x is minus 1 now. When x is minus 1, we'll actually have minus 1 times minus 1 square plus x, that's plus negative 1, plus 7. So actually minus 1, and this is 6, so that's 5. This would be 5. And the last one, when x is 3, y equal to minus 1 times 3 square plus 3 plus 7. That's actually minus 9 plus 10. That's 1. That's 1. Alright, so now we are asked to do a graph. Do a graph to represent the function we just did. Alright, so let's plot the points. So the first point, let's plot the points. So we have minus 3, minus 5, and minus 2, 1. Alright? So minus 3, minus 5, and minus 2, 1. So minus 3, minus 5, and minus 2, 1. Those are 2 points. Minus 3, minus 5, minus 2, 1. Let's plot 2 more points. Minus 1, 5, and 0, 7. Minus 1, 5, and 0, 7. So minus 1, 5, and 0, 7. That's there. Alright, next. 1, 7, and 2, 5. So 1, 7, and 2, 5. Alright. And the final 2 points, 3, 1, and 4, negative 5. So 3, 1, and 4, negative 5. So 3, 1, that's 3, 1 here. And 4, negative 5 would be about there. Alright, so let's do our graph. So the graph should look something like that. So freehand is a curve, so it should be freehand, right? So a graph should look something resembling that. Let's see, 2, 5. Alright, so that's our graph. Write down the coordinates of the maximum or minimum point. So it's a maximum and the maximum point. So the x-coordinate, so if you look at this is 0.5. So it seems to be like this, it seems to be 0.25. I think I plugged the wrong point there, 17. 17 is actually 17 is actually this point. It's actually 17. So let me just correct that. So this is not a point. Alright, so 17 was actually this point, alright? So the maximum point would be here, somewhere here. Alright, so this point is, this is what actually 0.5 or half, and this would be about 7.2, so 0.5, and this seems to be 7.2. So the maximum point is 0.5 for the x, and 7.2 for the y. Write down the equation for the axis of symmetry, and the axis of symmetry is a line that cuts the thing in two. So the axis of symmetry goes straight through the turning point. Alright, straight through the turning point. So this is a graph x equal to 0.2. This line divides the line in two equal parts. So this is axis of symmetry is the line x equal to 0.5. Use your graph to find the solutions of the equation minus x squared plus x plus 7, and that's where the line cuts the x-axis. Alright, the line cuts the x-axis. If I'm using the graph, this is minus 2.5 and positive, well, minus 2. So this is negative 2.5, so minus 2.25 and positive 3.25. So where the line cuts the x-axis, where the y is 0, notice is the y-axis. Alright, so 3.25 and negative 2.25. 3.25 and negative 2.25. On the graph paper, draw a line through the points negative 3, negative 1 and 0, 8. So negative 3, negative 1, negative 3, negative 1 and 0, 8. So negative 3, negative 1 and 0, 8. Alright, so if I draw a line through, alright, this line should be something like this. So that's a line. I guess it cuts the curve, the curve at minus 1, positive 5, it would seem. But anyway, let's see what they're asking us. Determine the equation of this line in the form y equals mx plus c. Alright? So we need the gradient m. So we know the line cuts the x-axis, the y-axis at 8. So we know c is 8. So the gradient, let's find the gradient m. Alright, so we can find m equal to y2 minus y1 over x2 minus x1. We can call this x1, y1, x2, y2. So y2 minus y1 will be 8 minus y1, so minus negative 1. And then x2, that's 0, minus x1, minus negative 3. That's actually 8 plus 1, that's 9, over positive 3. So the gradient is 3. So the equation is y equal mx. Now m is the gradient, which is 3, so 3x, plus the constant c, 8. Alright, remember c is where the line is, the y-intercept is where the line cuts the y-axis. And it cuts it at 8. Alright. Question 9 is on trigonometry, circle theorem. So element L, where's L? L, M, N, are points on the circumference of a circle with center O, here's center. PQ is a tangent to the circle. PRL, angle here 48 degrees. Angle RON, that's 156 degrees. We're asked now to find the value of each angle given the reasons. So find the angle R. Now angle R is this angle, and we know that angle subtended. Now if you look at this card, RN, the angle at the center is 156. Now the angle at the center is always twice the angle from a circumference, as long as the angle is subtended from the same chord. Alright, so the angle at angle R would be half of 156. Alright, so angle R is half of 156. What's half of 156 now? 78. So angle R is 78 degrees. So this angle is 78 degrees, and the reason, angle formed at the center is twice the angle formed at the circumference. So angle formed at the center is twice the angle formed at the circumference. Alright? What other angle are we asked to find now? Angle E. Angle E, that's this angle. Angle E. Now, what you'll notice is that this triangle is an isosceles triangle. Alright? Angle O, triangle ONR. ONR is an isosceles triangle. Notice, so this angle is 156. So these are O to R and O to N represent the radius. So these are opposite sides equal. So opposite angles will be equal. Now angles in a triangle add to give 180. So these two angles, this is 156. So these two angles should add to give 24. So this would have to be 12 degrees. And this would have to be 12 degrees. Since they have to be equal. Alright, since the isosceles triangle we have here. So 12 and 12, that's 24. Add 24 to 56. We should get 180. Alright. Also, angle between the radius and the tangent is 90. So this angle is a right angle. Between OR and the tangent is a right angle. 90 degrees. So if this is 12, then angle E would have to be 90 minus 12. So angle E would have to be 78 degrees. So there's actually two reasons, right? So this 12 is from the isosceles triangle, and then to get angle E would have to be 90 minus the 12. Alright, so angle E would have to be 90 minus 12 degrees. And that's how we get the 78. Since angle between the radius OR and RQ, the tangent, is a right angle, 90 degrees. Alright, so angle E, that's 78. What other angle are we asked to find? Angle A. Angle A, which angle is angle A? So angle A is this angle. Now again, the angle between OR and RP is a right angle. Since RP represents a tangent and OR is a radius, angle between the radius and tangent is a right angle. So if this section is 48, then to make the right angle, this would have to be 42 degrees. We also know that angles, the opposite angles, the sum of the opposite angles in a cyclic quadrilateral is 180. So notice we have a cyclic quadrilateral there. What's a cyclic quadrilateral? It's a quadrilateral where each vertex is on the circumference. So notice M, N, R, L. Alright, let's see the quadrilateral there, 4 sides. So the opposite angles, so M, which is represented by angle A, plus the quadrilateral here. The quadrilateral here is a combination of 12 and 42. Alright, a combination of these two angles, 12 and 42, that's 54. So A plus 54 should be equal to 180. So if I subtract 54 from both sides, A should be 180 minus 54, which is 126 degrees. Alright, so that's that. So A is 126 degrees. Alright, next. The diagram below shows a triangular field LMP on a horizontal ground. Calculate the value of angle MLP. MLP. So of course we have all three sides. So we can use the cosine rule. The cosine rule will say that this square, 180 square, is equal to the other two sides square. That's 150 square plus 120 square minus 2 times these very same sides, 150 times 120 cos the opposite angle to the 180, which is cos L. Alright, so applying Let's do the calculation. So 180 times 180, that's 32,400. 150 times 150, that's 22,500. 120 times 120, that's 14,400. Minus 2 times 150 times 120, that's 36,000 Cassel. So we can do some transposing here. So I'm going to transpose for Cassel. So I'm going to put group this, so 36,000, I'm going to put it down here. So 36,000, I put it on the left hand side. Positive 36,000 Cassel is equal to, group everything else on the right hand side now, 22,500 plus 14,400 minus 32,400. So I'll end up with 36,000 Cassel is equal to, so let's add up these numbers on the right hand side. That's 22,500 plus 14,400. And that with 4,500. So to get Cassel by itself, and I'll now need to divide both sides by 36,000. I get 0.125. So divide both sides by 36,000. So Cassel equal to 0.125. So L would be cos inverse 0.125. So L would be equal to 83 degrees, 83 to the nearest degree, alright? So L, this is 83 degrees. Run off to the nearest whole number. Alright, next we're asked to find the bearing of P, or the question says the bearing of P from L is 210. The bearing of P from L is 210. The bearing of P from L is 210. So this angle is 210. The bearing of P from L is 210. The bearing of P from L, so from L means from the north of L. Alright. So the bearing of P from L is 210, which means that the angle there, 210 minus 83. So this angle here will be 127 degrees. Alright, what else are we told? Oh, find the bearing of M from L. So the bearing of M from L, so that's it, 127 degrees, because the entire thing around is 210. So the bearing of L from L will be 210 minus 83. Alright, and we found that to be 127 degrees. Next, calculate the value of angle NLP, and hence find the bearing of L from P. So find the angle NLP first, bearing of L from P. So NLP, NLP, that's this angle. Notice this angle around is 360. So angle NLP, that's this angle, will actually be equal to 360 minus 127 minus 83. And that should give us that's 360 minus 127 minus 83. That should give us 150 degrees. So this angle is 150 degrees. Next, we're also asked to find the bearing of L the bearing of L from P, the bearing of, what is it? The bearing of L, the bearing of L from P. So from P means from the north of P. Alright, to L, that's this angle. That's this angle we're asked to find. Bearing of L from P. So from the north of P to the line that goes to L, that's this angle. So we can find this angle quite easily. Now let me use a different color ink just to differentiate. Alright, now we know angles on a straight line add to give 180. So this is 150. If I should extend this out here, this is 150. So this section will be 30 degrees. This is 30 degrees. And this angle, this 30 is alternate, so this is also 30, since these are alternate angles. Alright, so this is also 30 degrees. This is 30, this part is 30, hence this part is 30. So the bearing of L from P is 30 degrees. Alright, and if we want NLP was what again? It was 150 degrees. Alright, let's move on to the final question, vectors and matrices. Question 10. The matrices A and B represent the transformations given below. So A, we are told this matrix represents an anticlockwise rotation of 90 about the origin O. B, and this matrix represents a reflection in a straight line y equal negative x. Determine the elements of the matrix C, which represents an anticlockwise rotation of 90 about the origin, followed by a reflection in the straight line y equal negative x. So to get the matrix C, the combined matrix C is just is the first matrix, anticlockwise rotation A, followed by, now the followed by, that's very important, the followed by comes, the matrix comes before. Alright, so reverse the order. So BA. So C is equal to BA, and remember BA is not the same thing as AB, since matrix multiplication is not commutative, so the order is important. Alright, so the first matrix A, anticlockwise rotation, followed by the reflection in the straight line, this B, and so B comes at the front. Alright, so C would be B, which is 0, minus 1, minus 1, 0, times A, which is 0, minus 1, 1, 0. So remember, it's row by column. Alright, so C is equal to row by column. So 0, negative 1 times 0, 1, that's negative 1. 0, negative 1 times negative 1, 0, that's 0. Negative 1, 0 times 0, 1, that's 0. Negative 1, 0 times negative 1, 0, that's positive 1. Describe geometrically the single transformation represented by C. So if you notice, let's multiply it to a point and see what happens. If I just choose a random point, let's say for example 2, 5. And I multiply this matrix to 2, 5. If you notice, what will happen is that the x coordinate will change sign. Alright, so multiply negative 1, 0 times 2, 5, you just negative 2. And 0, 1 times 2, 5, you get 5. Notice all that would happen is that the x coordinate will change sign. Alright, what type of transformation does that? It's a reflection. So this transformation represented by C is a reflection in the y-axis. Because when a coordinate is reflected in the y-axis, the x-coordinate will change its sign, and the y-coordinate remains as it is. Part B, a transformation T is defined by the following 2 by 2 matrix. So T equal 1, 2, K negative 1, where K is a constant, t maps 2, 3 onto the point 8, 15. Determine the value of k. So t maps, so when you multiply t, when we say t maps 2, 3 to 8, 15, all we mean by that is that we multiply the matrix t to 1, 2, k, negative 1 by 2, 3, you should get 8, 15. Alright, so it means let's expand. So apply, if you notice, apply the top row, the top number, 1 times 2, that's 2, plus 2 times 3, 6, so 2 and 6 give us 8. Alright, multiply the bottom, apply the bottom row to the column here, so k times 2, that's 2k, minus 1 times 3, that's minus 3, should be equal to the bottom number 15. Now what is the top one? 1 times 2, 2, 2 times 3, 6, 2 plus 6, that gives you the top value here, which is 8. Alright, so we have 2k minus 3 equal to 15. We group the constants on the right hand side, so 2k equal 15 plus 3, so 2k equal 18. Divide both sides by 2, k is equal to 9. Vectors, so we have 3 vectors there. We are asked to find a vector other than 5, negative 1 that is parallel to WX. So parallel vector, just multiply the vector by any constant. Alright? So parallel vector, a parallel vector to WX is, you can multiply WX by any constant. Let me multiply a simple number 2. 2 times 5, that's 10. 2 times minus 1, that's minus 2. Or any other constant. So 10, negative 2 is a parallel vector to 5, negative 1. Alright? Find the vector WY. Now let me do actually we have 3 like WX, Y, and Z. So let me actually do a triangle just to show you something quickly. Here's a triangle. And you can put WX and Y anywhere on the triangle. We also find the vector WY. Think of yourself, you're walking and you want to get from W to Y. Alright, how do you get from W to Y? You can go straight from W to Y, or you can go W to X and then X to Y. No, W to X, WX, no. WX is 5, negative 1. And XY is negative 3, 7. Add these two vectors. 5 plus negative 3, that's 2. Negative 1 plus 7, that's 6. Alright, next we're asked to find the vector XZ. So XZ, again, think of yourself walking. You want to get from X to Z. How do you get from X to Z? Let me just use the same. I need to have a Z now in this thing here. Let me just put a Z in this diagram here. Z can go anywhere, so I'm going to put a Z there, alright? You need to get from X to Z without walking directly from X to Z. Now, how do you get from X to Z? You can go, to get from X to Z, you can go X to Y, X to Z, a different path. You can go X to Y, and then Y to Z. Alright, to get from X to Z, you can go X to Y, and then from Y to Z. Now X to Y is negative 3, 7, there it is. And Y to Z, no, we have ZY. We have ZY, so to get from Y to Z, the thing about vectors, direction is important. So if direction change, the sign also changes. So what you really want is YZ, which is the opposite direction. So YZ, just change the sign. So YZ is actually minus 8 and positive 7. So yz is actually minus 8 and positive 7. So you add these two vectors, you actually have minus 11, 7 and 7, that's 14. Alright, and that's it.